Again, lesson 7 will be the second thing on your quarter 3 grade as a heads up. Okay. So lesson 7 is all about adding and subtracting polynomials. This whole unit that we've been working on is about polynomials. We've talked about monomials. Poly, the prefix poly means many. When you see the word monomial, that just means one term, right? So polynomials are multiple terms, many terms. So your learning target for today is by the end of this lesson, you'll be able to add and subtract monomial expressions. And you know what, you guys, actually, if you completely understand the concept of like terms, this lesson will be on the easy end for you. Okay, if you struggle with understanding what like terms are, this might provide a little challenge for you, but that doesn't mean that it's not doable. So let's get right into it. All right, so here is our first example. We're going to simplify the expression. So take a moment and write this problem down, this math problem. The quantity of 2x squared plus 5x minus 7 plus the quantity of 3 minus 4x squared plus 6x. All right, so as I mentioned, understanding the concept of like terms is going to be really helpful for you. So all you're going to do when you add or subtract algebraic expressions like this, you're going to look for like terms. So we determine like terms by looking at both the variable and the exponent. So the first thing that I'm going to look at is I notice that I've got a term with an x squared, and then I go to the next set of parentheses, and I notice that there's this negative x squared. Okay, remember that the operation, either the adding or subtracting, belongs immediately to what's immediately following it. So I've got 2x squared and negative 4x squared as like terms. I've got 5x, and then I go down here, and then there's a positive 6x. And then I've got negative 7, and then that positive 3. So if you have highlighters or color pencils or something at home, feel free to do what I just did just to make sure that you're matching up those like terms. Or you could do like circles, triangles, squares, something to that effect, just to make sure that you're matching up those like terms. Then all you're going to do is combine them like we've talked about. So we've got 2x squared minus 4x squared. And we know that when we add algebraic expressions, the base and the exponent stay the same. So you'd simply just do the coefficients. 2 minus 4 is a negative 2. Then I do the same thing with the x terms. I've got 5x and I've got 6x. When I add those together, notice it becomes 11x. I will tell you a common misconception or mistake with this is that sometimes kids will tell me that this is 11x squared. Okay, when we're adding and subtracting, this variable has to stay the same. And then our last term is just to do the negative 7 plus 3, which gives us the negative 4. Now, you wouldn't leave your answer as this because you're adding these algebraic expressions. You're going to take each of those parts and put them into one, one final last algebraic expression. You're going to put it together. So the answer for this is negative 2x squared plus 11x minus 4. Just one thing to note, again, because there is a subtraction right here, we're going to put that subtraction, and because 11x is positive, that's why we put a plus there. So if they're positive, you're going to add those terms. You're going to put plus in there. If it's a negative, you're obviously going to put that subtraction in there. You might also, if you want, you might also consider doing 2x squared plus 11x plus negative 4x. That's just something else that you could do, but you don't have to. Either of these answers is acceptable. And I believe last week somebody asked, what order do we write? Does the order that you write them in, like put them in, does that matter? Not necessarily, but it's just common. It's a common strategy, isn't the right word. It's like algebra etiquette, I guess. Putting them in descending order by the exponents. Okay, that's why you see mine as negative 2x squared plus 11x minus 4. All right, let's go to our second example. Again, we're going to simplify, so please take a moment and write that algebraic expression down, and then we'll walk through it just like we did the last example. So we've got 3 minus 2x plus 2x squared minus this quantity of 4x minus 5 plus 3x squared. So the first thing that I'm going to suggest that we do is take this negative outside the second set of parentheses and distribute it through this entire expression. We're going to multiply each of those terms by that negative. Okay, so then that turns this entire problem actually into an addition problem, and we seem to have fewer mistakes when we have addition problems. And then from here, you can break it up like we did the previous problem where you're looking for the highest term. So again, I notice that I've got my 2x squared. And I look down the line, I've got this negative 3x squared. And then I've got this negative 2x, negative 4x. And then orange. And then I've got 3 plus 5. Okay, so I'm going to do the same thing that I did in the last one, is I'm just going to take each of those matching parts, those like terms, and do the math, simplify those expressions. So 2x squared minus 3x squared is negative, remember there's an imaginary 1, so negative x squared. Then I'm going to do negative 2x minus 4x, which is negative 6x. And then I've got 3 plus 5, which is 8. And then just like I did in the previous example, I'm going to take all 3 of these terms and then just write them as one algebraic expression. Negative x squared minus 6x plus 8. Again, I will say distributing that negative through in that second term is going to help minimize our mistakes. I'm not going to say it's going to eliminate the mistakes, but it will definitely minimize the mistakes that you will make if you remember to distribute that negative through. Okay? All right. Those are my 2 examples. What questions do you have about either the first one or the second one? All right, on your note paper, here's your closure. What do you need to do first when subtracting polynomials? So what was it that we just talked about? Your sentence starter could be something like, when subtracting polynomials, you need to remember to All right, if you haven't done so yet, go ahead and head over into Schoology, refresh that folder if you don't see, or refresh your screen if you don't see the CCA 7 folder. What color are we this week? Blue? Purple. All right, so look for that purple folder, and inside that purple folder, you will see the Lesson 7 assignment. And the rest of class time is for you to work on that assignment. Or go back and work on previous assignments from the last unit, since it is the last week.